Let me see how many people gathered in the class.
15.
15, okay. Okay, I wish there would be more listening to my opinions. Yes. I have a few suggestions to you, because during these 15 weeks, I think we had the opportunity to have some opinions about each other. You should tell me your opinions, and I am going to give you feedback. Yeah. My first point is to suggest you, to advise you, ask questions. Ask questions. Okay. You only can learn by asking. And there are colleagues in this class who participate in the class and who cooperate with the teacher to make the learning activity a success. This is very, very much necessary, I believe. So I suggest you to participate in the class, not just to learn in the class. This is a way to learn. If you participate, you learn. So learn in the class. In the class. Okay, there are some courses, such as anatomy maybe, where you have to go and practice at home, try to memorize. But some other courses, including mine, I believe, you may learn in the class while the professor is instructing, giving you a speech. So this is only possible when you actively participate. And I know that some of you, maybe they are studying with scholarships, but most of you are paying to learn, paying professors to appear in the class and give you some speech. So make benefit from that. Try to get the maximum of that guy, of that lady who is teaching you. If I would be, that always, people tell this after some age, but let me tell you, if I would be in your age, with my current opinions, I would squeeze the professor. I would ask him all what I have in my mind to learn. This is an opportunity you will not get again. Okay, you may believe that biostatistics maybe is not that much important for you, but if you have this learning hour, 1 hour, 2 hours in a week, it is a time you have to spend anyway. So why not to make maximum of it? In my opinion, although I have to admit that there are colleagues who tried to participate in my class, to try to raise their hand and say a few words or ask questions, participate. That was not as much as I was expecting. This is the first feedback I want to give you. The second feedback is how should I say this? The second feedback is you didn't appear in the class. Most of the students, they didn't show up. Yeah, I know you are much, the number of students in this class are much more than 22. So why are only 22 here? Where are the others? It means maybe they are watching the recording. Yeah, that's possible. But then You can watch so many good YouTube videos or read other articles out there in the internet. You don't need me. You don't need to watch my videos to learn. You can watch much better videos, available ones. If you want to, if you want to spend some time on that, I would suggest to be in the class of the professor. My class is finished now, but I am advising you for your future career. If you are giving a learning opportunity, so use it, appear in the class. You are already here, but I am telling this to those who are not here. But I'm not sure whether they will hear my voice. So this is the second point. Yes, our feedback to you will be in a manner, the scores you get will be a feedback, but that's not enough, The scores are just something physical or a summary of your learning. But I wanted to add my personal opinions, subjective opinions. And we also want you to give us feedback. So please, I will try to share in the chat now feedback. Let me pass this our, where's this chat screen here? Yeah, it is. This was our feedback form. I submitted it through the chat screen. So please, as I am telling you honestly my opinions, we would be happy to hear and read also your opinions about our class, so that next time we will do it better. We will improve our performance, hopefully. Okay, that was that much preaching. Sorry if I bothered you. Now let's go over to repeating what we have learned. If you have questions, I will be delighted to answer them. Please, if there is something you didn't understand, I will go briefly through the most important issues I believe you should remember from this biostatistics course. I briefly will go through them. But if you have questions, please ask them.
I don't have questions for now, Mr.
Yeah, thank you. It's so nice for a teacher to hear some voices, have some eye contact if you are in the class. But if you speak and nobody is, it seems that nobody is listening to you. That's very annoying. Okay, thank you. You remember this was probably the first or second class when I have spoken about the variables or data types. The variables are the most crucial part of this course, because if you don't understand the variables, you will not understand anything else. You will not be able to follow how to formulate a answerable clinical question, the PICO format, or how to decide which hypothesis test you will use for which scenario, for which condition. So let us briefly go once more over these variable types. We had two types of variables, categorical and numerical. Yes. And here you see that the categorical variables are further divided or subcategorized into nominal and ordinal, while the numerical ones can be divided into discrete and continuous. Do you remember how it was in the SPSS?
Yes, in the SPSS, numerical value was added by scale in the one title.
Very good. These two in numerical are called scale. In SPSS, they are called the scale variables. They're merged together. So these are one kind of treated as one kind of variable. Why is that? Why SPSS, the developers of SPSS, they have decided to have these two categories? They know very well that these are actually two distinct categories. Why they merged them together in the SPSS? Because, yeah.
Sorry, Mr. Because in the SPSS, there you might decide the decimal points, like whether if you don't want to, you can just shift.
Yeah, you can just shift it, and the analysis of continuous and discrete variables is the same. It doesn't matter whether you have a discrete or continuous variable, you will have the same analysis, same. It doesn't make any point, any change in the SPSS. But theoretically, we know that we have discrete and continuous. And there was something else concerning the data types. We have a nominal and ordinal. And ordinal, you know, here are some examples: mild, moderate, and severe. Like mild is 1, for example. Moderate is 2, and severe is 3. So this is an ordinal variable. And sometimes we could treat an ordinal variable as it is numerical. Do you remember that I had spoken about it? Sometimes it is possible. What do I mean by this? Categorical variables we present as what when we do the statistics? How do you present categorical variables?
Like 1 as a female, 2 as a male, for example.
Very good. And how do you summarize them? How do you make, if you have, let's say, a class of 50 students, they participated in the survey, and you want to give the information about the sex, male and female. How do you present your data?
We just give the number and the percentage.
Very good. The number and the percentage. Okay. So if you have a categorical variable, the rule is you give the number and the percentage. But for ordinal variables, you may give the number and percentages, how many people had the mild disease, how many had the moderate disease, or how many had a severe disease, mild, the N and percentages. But you may also treat them as if they were numerical. If you treat them as a numerical, what you are expected to present, a numerical data?
Mean, median, range.
Very good. Mean. Mean, we show with the X bar, mean, and standard deviation. Hence ST, right? Mean and standard deviation. So if you have a numerical data, you present it as mean and standard deviation, mean plus minus standard deviation. If you have a categorical data, you present it as N and percentage. Always N and percentage together. Giving only percentage would not be enough. Always mean and standard deviation together. Giving the mean only would not be enough. You should also present the standard deviation. But the mean we present for when there
normal
are
distributions.
Very, very good. There are situations when it is not safe, it is not suggested to present the mean. And these are normal distribution. Normal distribution. So normal distribution. Mean you can give if there is normal distribution. If you don't have normal distribution, if you have a skewed data, what do you mean by skewed data, by the way? It can be right skewed or left skewed. Is
We
this
just give the ranges.
is this a right skewed or left skewed data?
And the medians?
Yeah. What kind of data is this? Is it if this is the histogram of the
Left
data?
skewed.
It is left skewed, yeah. If the tail is the, so if I ask by showing you this graph, where are the extreme values here, outliers?
On the left side.
They're on the left side, yeah. So extreme values are here. These are the extremes or outliers. Do you remember the difference between extreme and outlier? Not that much important. Extreme is more far in the left, outliers somewhere here. Okay, that is a detail, but I have spoken about it, I remember. So you try to give your mean and standard deviation for numerical data, but if it is not possible to give the mean and standard deviation, you give, as it is in this case, as you have a skewed data, you give the median, and together with the median, you have to give the range. Range means what? Range?
Like the maximum and the minimum point?
Yes, minimum and maximum. You give the minimum, maximum, or the range. Okay. So please allow yourself 10 to 15 seconds to think about different examples of nominal, ordinal, discrete, and continuous data. I would be happy if each student in the class would give me some examples. I know it will not be possible, but I would be very happy if I can call out your names. You give me some examples. Okay, have you thought about different variable types? Very good. Let me read from my list here. Abdullah Kasimov. Do you have an example for nominal data, which is not mentioned here?
Good morning, teacher.
Good morning.
It's like a nominal.
Give me an example of any other data, if you have.
Like level of hemoglobin in the blood. It's like a numerical discrete.
Again, can you repeat again? I didn't understand what you said.
Like level of hemoglobin in the blood.
Hemoglobin, okay.
Yeah.
Hemoglobin level. Thank you. Thank you. Yeah, it's correct. It is discrete or continuous hemoglobin?
Continuous.
It is continuous, of course, yeah. Hemoglobin, it can be what? What is your hemoglobin probably?
15.
15.2, let's say. Huh? It usually it has a comma and it has a decimal value. Milligram per deciliter. Okay, thank you. Aliza. Do you have an example of nominal data? Aliza not there. Alperen. Alperen orada mısın? Okay. I'm used to this. Epic. Yeah.
Here.
Please. Go ahead. Nominal data. I need examples for nominal data. Hey, my dear students, colleagues, future colleagues.
Marriage studies?
If you are not able to give examples, correct examples for these 4 variable types, you will not be able to pass this class. I guarantee you. Again?
Marriage status, whether like married, divorced, or not
Yes.
married.
Okay. Marital status, yes. Marital status, married, single. Very good. This is nominal.
Gender, hair color,
Gender is here, yeah. What else?
hair color,
Hair color. Thank you. Yeah, hair color is good. Is a good example. Hair color. Hair color. Yeah, blonde, dark. Okay, black, brown. Colors.
Can I
Maybe
say?
And
nationality.
you,
Can I
country
say
name?
Yes, please.
whether drinking alcohol or no?
Okay. Yeah. Very good. Alcohol consumption. Alcohol consumption status. Okay. It is. What would be
And
the options?
smokers,
Smoking status. Yes.
maybe they are not.
Yes. Yes and no. Okay. Very good. Okay. Good. What about the ordinal data? Ordinal data. Arc
Can I
Tarakai.
say,
Yes.
Mr. Can I say sleeping duration of sleep 3 hours, more than 3 hours, less than 3 hours?
Okay. So duration of sleep.
Sir,
Duration.
BMI, like normal,
BMI.
below and high.
Very good. So let us discuss these two. Duration of sleep. And BMI. Okay. So BMI low, medium,
Low. Yes, and high.
and high. Yes. And duration of sleep.
3 hours, more than 3, less than 3.
3 hours. Okay. Okay. 3 hours. 3 to 5 hours.
This is more than 3.
6 to
And
7 hours, let's say. Okay. Anyways. So, in fact, if I ask you from the opposite side, from the reverse, if I ask you what kind of variable is BMI, what would be your answer?
numerical.
Yeah,
It's numerical.
it's a numerical variable. If I ask you what is the duration of sleep, duration of sleep is hours, huh? Hours. BMI is kilogram divided by meter squared. If I ask you what kind of variable is the duration of sleep, hours,
Also numerical.
also numerical. So
But
these are actually numerical variables, but you converted them into ordinal,
yeah.
categorical. Yeah, okay, very good. We agree, yeah. I agree with you. There is no problem in converting numerical variable into categorical. But remember, please, I told you, I made you an advice in the beginning of when I was teaching this topic. Although it is possible to convert numerical data into categorical, as you did here, duration of sleep and BMI, you decided that they are ordinal or categorical variables. But in fact, they are numerical variables, numerical continuous variables. So you convert them into ordinal variables, but it is not possible to convert them back. You see this arrow? It's going only from numerical to categorical. It is not possible. Once you have collected the data, you ask me, how long do you sleep in a night? And I tell you, I sleep 6 hours. I select this here. Okay. And when you are going to analyze, is it possible to take, because if this is a numerical variable, it should be possible that you give the mean and standard deviation. But if you collect it as a categorical variable, if you convert it into categorical before you collect the data, it will not be possible for you to go and take the mean and standard deviation of it. So you will lose some very valuable information. You will not be able to conduct the parametric tests. Do we agree? Therefore, I strongly suggest you to restrain from asking a numerical variable as categorical, converting it into categorical. When you are asking in your study, in a research, when you are asking about a numerical variable, please collect the data as numerical, as it is. Ask my age. Don't give me options for age. Ask the age. Okay? Ask the BMI. Don't give options.
Okay. Yeah, I get it, sir.
Thank you. If you don't understood, I'm happy. Okay. So this was for ordinal. Now let's collect some examples for discrete data, numerical discrete data. BMI,
Yes, hocam.
numerical discrete data, please. Days sick last year, for example, is an example in the book. Yeah. If it comes to your mind, please tell me. I need more examples. Okay. Who else? Durab. Numerical discrete. Faiz Yasin.
Actually,
Hamza.
high and weight
Yes, sir.
also can be numerical discrete.
Number of days in a week, number of months in a year.
Okay, very good. How many days, how many years, how many months has passed, for example? What was the example for BMI? BMI's example I couldn't hear. Okay. Yes.
How many years did you study in university?
How many years? Yeah. How many years did you study? How many days? These are usually given as
Work experience, how many years?
work experience. Again, years. Okay. Other than years and months and days, do you have
Number of
something?
classes you took.
Yeah. Okay. Number of classes. How many
Maybe
classes?
psychological attacks. How many times did you have psychological
How
attacks?
many
For?
attacks you had? Yeah, very good. Okay, number of attacks, very good. Number of attacks is a new example, yes. How many
Okay.
attacks?
How many appointments you have?
Oh, good, great. Yes, how many appointments, how many doctor appointments did you have during the last year? Yeah, very good examples. That
Number
makes
of
me happy. That makes me happy.
patients.
Number of patients, how many patients came in? Yeah. How many patients were discharged from the hospital in a day? These are all discrete values. And when we come to the continuous, that's the easiest variable, I believe. Kiran, do you have examples for continuous variables?
So she has internet problem.
What did you say?
She has internet problem.
She has internet problem. Okay. Then who else is there? Hamza, Mohammed Hanzala, Mohammed Reza.
Yes, sir.
Yeah. Examples for continuous variables.
Sir, leap years.
Continuous. When I say continuous, you should have in your mind what? You should have the scale in your mind. Huh? Scale. Something you can measure. Continuous.
Temperature, length.
Like temperature, like body temperature, huh? Centigrade Celsius.
Body weight lost in a specific
Weight.
time.
Yes, weight. What else? In fact, all the laboratory values you measure in the blood are
Hematocrit
numeric,
values, CBC
yeah.
values.
Yeah, CBC, hematocrit. Okay. CBC, CBC means complete blood count, and it has many, many other variables in it. For example, leukocyte count, white blood cell count, white blood cell count. Is this an ordinal, the continuous or discrete value? White blood cell count.
Sir, it is, I think, continuous because it changes.
Can you have, do you know the approximate number of white blood cells in a milliliter of blood per milliliter?
Maybe about 4 to 5.
4
It
to
is
5
3
what?
to 1,000 to 12,000.
4 to
Yes,
5
very good,
milliliter.
very good. Okay, yes, let's say 6,000, huh? 6,000 per milliliter. So can it be 6,000.1? Can it be half, a half
No.
white blood cell? No, white blood cell is a discrete number. Huh? The number of white blood cells. How many white blood cells do you have in your blood? So it's a discrete variable. It's not continuous.
Sir, in continuous, the values are changing, not they are in a specific order. So I think
Uh,
when a patient gets sick and anything like infection, so these values changes.
I wouldn't say it like this. A better expression would be if you have continuous variable, it means you may have a decimal place, comma, like 20, 3 or 20.3. 20.3. If you're not possible to express your variable with a comma, it means it is a discrete variable. Okay?
Yes, sir, got your point.
Continuous variables should be able to have a comma. White blood cells are discrete variables, integers. They cannot have comma. You
Teacher,
cannot have a half white blood cell. Yes, please.
maybe changes in the level of carbon dioxide during the exercises.
Changes in the, changes, but changes are continuous. You will express it in percentage.
Okay.
If it is a percentage, if you
Sir,
give it,
keratin levels in urine.
okay. What levels? Keratin?
Yes, sir.
What is that? Keratin, I don't know what it is, but okay. Something you measure in urine
Yes, sir.
would be,
Sir, it is like uric acid. It is in decimal.
okay, uric acid. Yes, uric acid I know, but keratin I didn't know what it is. Sorry. Very good. So once you understood the different variable types, and I feel happy that you have very sound knowledge now about the variable types, you should be able to tell me which hypothesis test I will use for which kind of variables. Therefore, yes, you remember we had for different tests for numerical variables and categorical variables. If you have a numerical variable, and you measure it in one group, you compare one group, you compare it with a known mean. Which hypothesis test you are going to do? Do you remember the test?
One sample
Yes.
test.
Yes, the one sample t-test, or this was the parametric test, or the non-parametric
Non-parametric test.
alternative was
Sign test.
sign test, the sign test. Yeah. If you have numerical data,
Sir, can you wait, please?
yes, please.
Sir, I just want to note this one in my notebook. This one. Yeah, go.
Okay.
Thank you.
Yeah. If you have two independent variables, numerical data, two independent variables. Example, you measure the numerical data like body weight, and you compare two independent groups like males and females. Then the test you have to do is the independent.
Parametric test is unpaired.
Yes,
Test.
independent samples,
Also known
t-test,
as student test.
also known as student t-test, student t, or also known as the unpaired t test. If you cannot perform this parametric test, then the non-parametric alternative would be
Wilcoxon rank sum test.
Rank sum test, or in SPSS we have the Mann-Whitney
test.
U-test. If you have a numerical variable, but two related means what? Two related means repeated
Paired.
measure. Huh?
A single group, but we do two measurements.
Yeah, two measurements, paired, or two measurements of a numerical variable. Then your parametric test would be
Paired t-test.
Paired t, and your non-parametric alternative would be
Wilcoxon sign.
the Wilcoxon test. If you have a numerical variable, but more than two measurements, more than two categories, numerical variable, more than two categories. Like you measured the body weight between students in class 1, class 2, and class 3. You measured the scores of students from Aratu medical students, Marmara medical students, and Munich Technic medical students. You have three groups. Your parametric test would be?
One-way ANOVA.
Yeah, one-way ANOVA. Did you ask yourself if there is a two-way ANOVA? You should ask.
Is there?
Yes.
Okay.
So this one is what we have one numerical and the other one is categorical.
No, you have a numerical variable, you compare it between more than two groups. Groups are categorical, of course, but it wouldn't be correct to say categorical. More than two groups.
I have two groups of numerical.
More than two groups.
Okay.
More than two groups, you are comparing a numerical variable between more than two groups. Your parametric test is one-way ANOVA, and your non-parametric alternative is
Bruscal-Wallace test.
And so what's this above it? There's two independent.
Two independent?
Yeah.
This here?
Yeah.
Two independent groups.
Two independent group, and that one, the categorical, is two dependent group.
This is also more than two independent groups. Independent.
Okay.
ANOVA is for more than two independent groups. If you have more than two related groups, it means you measured the numerical variable not twice, more than two measurements. This actually we didn't discuss in the class, but I have given you in the test for it. Would you like to tell me?
ANOVA.
Yeah, wow. Yeah. More than 2 measurements.
Yeah.
This is parametric test is repeated measures ANOVA. And the non-parametric alternative of repeated
Friedman test.
is the Friedman's variance analysis. Yes, Friedman. So this much is enough for numerical. Then we had the categorical. Categorical, if you have a categorical variable, categorical outcome variable, such as smoking status, smokers, non-smokers, such as voting, saying yes, no, 2 categories. So categorical variable, 2 categories. And you have 1 group. 1 group. Do you remember the tests here?
Z-test.
Is it chi-square?
There's a Z test, the sign test. Sign test, yes. The chi-square. We have also chi-square here, yeah. But this, I didn't show it in the SPSS.
No, actually, you showed us.
Did I? I don't remember. Okay. If you have 2 categories, but 2 independent groups, then you do the chi-square. Always for the independent
and the Fisher's
groups.
exact test.
Yeah, or Fisher. Very good. Or Fisher's test.
So you said if it's 1 group, it is Z test. And what is the second one?
Sign test.
Sign test. Okay.
Yeah. If you have a categorical data, 2 related groups, 2 categories and related
McNemar's
groups,
test.
then you do the McNemar's test. Yes. If you have categorical data, more than 2 categories, here our example was smoking, smoking positive, smoking negative. Here we have more than 2 categories, such as blood groups, or hair color, or some other satisfaction level. Which test do you do if it is independent more than 2 independent categories? Let's say independent.
Chi-square.
If it is independent, always chi-square. Chi-square. If you have a categorical data, more than 2 related.
Paired marginal, if I'm not mistaken.
Wow, marginal homogeneity, but that we didn't show you. Huh? Marginal homogeneity.
You have mentioned.
I have mentioned.
Isn't it chi-square too again in the related groups?
And this marginal is the
related,
extending
no.
version of McNemar.
If it is, yeah, or extended, very good. Extended McNemar, yeah. Extended McNemar. You are great. You make me happy in this last session. Congratulations. Thank you. Extended McNemar we have also. Yeah. So believe me, guys, you will go and read, you must read some articles in the future when you become class 4, class 5. In the clinical rounds, your professors will ask you to read a paper. And there will be all these terms you see here, chi-square, Fisher exact, McNemar, ANOVA, independent samples t-test, paired samples t-test. All these names will come up there in front of you. And once you feel competent in this class, I'm sure if you remember them, if you forget them, it will be very easy for you to remember. You just need to go and to have a look at our book. You will remember it very easily, and it will hopefully, inshallah, I hope this will contribute to you in your future career.
Sorry, what's this two related march homogeneous?
Marginal homogeneity. Homogeneity. Marginal homogeneity. Extended McNemar. Yeah. Okay. Okay. Dr. Azamat, should I go into details for the other topics, or do you think this much something?
Not sure.
Yes. Let us talk a little bit also about the error checking and outliers. Okay. Here's my chat screen. I want to share this, the link for our form once more, for those who maybe didn't see it. Please fill it out, give your opinion about the class, and make us happy. We are two guys, Dr. Azamat and me. We did so much preparation for this class, especially Azamat. He followed you also for the practical sessions. So I think we deserve some feedback. So the other thing I want to discuss with you is about the errors, error checking and outliers. And yeah, if you have a skewed variable, in medicine, do we usually have right skewed or left skewed variables? Now I'm going to draw you a histogram. Nice question, I think. Huh? In medicine, do we have usually this kind of skewness or this kind of skewness?
Is it right skewed?
This one, huh?
Mostly it is middle.
Okay, in medicine, some guy there means in medicine we usually have symmetrical distributions. Yeah.
Yes, this one.
Okay, this is a good exam questions. Let me keep this in my mind. Which of these variable distributions is most commonly observed in medical practice? And the correct answer is A, B, and C. The correct answer is
B.
A. Why A? Imagine if you have blood pressure. In the hospital, you will have people with extreme values, high blood pressures. Most of the variables you measure in medicine have extreme values on the right side, on the higher side. There are, if you measure blood glucose, you will have in the hospital people with very high blood glucose. Ketosis, like 500, 600 blood glucose, they will come to the hospital. So therefore, in medical practice, in the daily, if I would ask you which of these distributions we observe in the community, then this would be the correct answer. B, symmetrical. Because in the nature, out there in the community, we observe this kind of distribution. But since in the hospital, in medical practice, we see sick people, we observe sick people. The sick people usually have right skewness. Rarely we have left skewed, like what? In variables where you have low measurements, like hemoglobin, for example. If you have measured hemoglobin, there will be people with low hemoglobin, which are sick. Okay, so if you have a right skewed data, by the way, the parametric tests, parametric test assumptions. Can you remind me on the parametric test assumptions?
homogeneity.
Normally
Yes.
distributed and sample size should be suitable.
Three assumptions, yeah. There are three assumptions. One is sample size, n sample size. Second is normal distribution.
And equality of variance.
And if you have independent measurements, then equality of variance. Equality of variances. Of variances. So if you have a skewed data like this or this, right or left skewed, then since you violate this normal distribution assumption, you're not you're not allowed to go and conduct the parametric test. But is there a solution for these extreme values? Is there a solution to deal with skewness?
Yes, we can transform them.
Wow.
Log and
Wow.
log transformation and
Wow, this girl should score 100 in the scorecard. Dr. Azam. Yes, you can transform. You can transform.
100.
If you want to transform a right skewed variable and to try to make it normal distribution, which kind of transformation you would prefer?
log transform
Left?
and square root.
Log transformation or square root transformation. If you have a left skewed data and you want to convert it into make it symmetrical, which transformation would be useful here?
Square transformation.
Square transformation, yeah. Boys, the girls are better. Please speed up. Try to
Mister,
catch them. Yes.
can you show this transformation from the SPSS? I tried it last time, but I couldn't.
Okay. It will be a pleasure to show it to you, yes. SPSS verileri, SPSS diabetes. Let me open my file. It may take a while. And by the way, I congratulate for the projects. Dr. Azamat has told me that there are very successful projects. Even if there is one successful project, I will feel myself as we accomplished what we aimed. And there are many successful projects. Thank you for the good ones. So if I do a histogram for, let's say, the weight variable, I expect that it is a little bit right skewed, because there will be obese people in the class, in the sample. There will be obese people. Let us see. It is not too much right skewed, but it is a little bit the right wing is a little bit longer compared to the left one. So, and I have enough sample size. So if I want to make it more symmetrical, if I want to get rid of these extreme values here, if I want to get rid of these extreme values or I want to modify them, one solution is transforming. And transforming in SPSS is done from transform compute variable. Did I show it to you? I'm not sure. Compute.
You did, Mister, but I forgot.
Okay, no problem.
Yes, sir, you showed.
You're not expected to do this. This is beyond our objectives for this class.
Actually, we finished the project one.
This weight, and I want, since it is a right skewed data, I want to make a log transformation. I give a name. This name can be anything, weight log or log weight. And my calculation will be an arithmetic calculation logarithm logarithm on the base of 10. Okay, I click to move it up here, and then I select my variable, weight variable, and add it here inside. You can write it by your hand. You don't need to, do all these attractions here, click there. If you know the formula, you can just write it like LG10 in brackets weight by hand. That will also do it. If I click OK, I will have a new variable here at the end of my list. I will have this new variable, weight log, you see. I have a new variable now. If I repeat my graph, histogram graph with my new variable, this new logarithmic transformed variable, I expect that it will be more symmetrical. You see, is it more symmetrical?
Yes.
Yes. Compared to this weight, this one is more symmetrical. But there is one issue I have to take care of. Here I have the mean of this logarithm transform data is 1.86. But actually weight, the mean weight is around 70 kilograms, 74 here. So if I write in my report, the mean weight was 1.86, nobody will understand, right?
So will we transform again?
I have to back transform this, yes. So 1.86, what is that? This is mean, the mean of log transform is 1.86. So what is I have to make a back transformation. Back transformation. Oops. Back transformation. This will be by what? If you remember from the math class, it is 10 over 1.86. I have to take 10 exponential 1.86. And let us do it. I need a calculator for this. 10 over, where is 10 over here? Here it is. 10 over, 1.86, 10 over 72.44. Okay, so in my report, 72.4 kilogram. This is logarithmic mean, by the way, logarithmic. Mean. This is what I have to write in my report. Okay. I calculate this 1.86, but when I am going to report it, I report the back transformed value. Okay, this was a detail, not so much important. Anything else you would like to discuss?
Thank you, Mr.
Welcome. You're welcome. Okay, the different charts, that will be also important for you. We discussed 5 different charts. The pie chart, which is very simple for categorical data, you give the percentage and n. The histograms, it can be used for categorical data. So here, histograms. Histograms are only for numerical variables. And the bar charts can be used for categorical data and numerical data. And we had the scatter dot. Scatter dot was for what? 2 numerical data. 2 numerical, you see, one numerical data weight and the other numerical data age. 2 numerical data. Yes. The average, the spread, This all I will not mention again. We discussed the norm theory distributions. Wow. Any questions about the theory distributions? Dr. Azamat. I think we shouldn't make the students too much tired. They should remember us positively. They should have a positive opinion in their mind. So these are enough from my side. If you can categorize the variables and select the correct test, that would be a success for us. Some of you, I'm sure, they will do also some research and they will take this further. But I don't expect everybody to be the same. Some of you may not like to do research at this stage. Okay, so
I have a
closing
question.
remarks? Any closing remarks? Yes?
A question.
You can
May I
ask
ask
questions.
something?
You can ask, yes, of course.
So
Like
like in
you mentioned.
categorical,
Okay,
Okay,
you go.
one by one.
okay. Like in categorical variable, if how many digits maximum can we take? For example, if we are measuring the blood groups, they are A positive, A negative, like this. So how many maximum can we take in our data? The digits from 1 to.
Do you mean what do you mean by digits?
For example, a digit 1 represents people with the A positive blood group, and like how many maximum can we take?
There is no maximum. There is no maximum.
Okay.
It can be 100 categories, but usually you don't have so many categories, because if you have too many categories, it's not possible to show it in your graphs, in your diagrams. Imagine, let us do for example, tables here. Some tables. Let us draw some tables here. If I have how many categories I have here? In the educational status, 5 categories, for example. Row percent, okay? Sorry, column percent. Move it right. Apply to all. Apply to all. Apply, close. Okay. You see, if I have 5 categories, I will have this small table. If I have 100 categories, this will not fit in my screen. It will be too many categories. You will not be able to present it in your screen. Then you must find a solution to merge the categories or decrease the number of categories somehow. Okay.
Thank you, sir.
What else you want to ask? There was another question, I think.
Yeah, Mr. You said that in the module 3 we will not have biostatistics exam. Am I right? Like you said that we'll have just
We will
finals.
have, I think, Dr. Azamat, we will have another biostatistics exam, I think, don't we?
We have a final biostatistics exam, but not module.
But the chart which they sent, there is a biostatistic. So what will we do?
If there is in the chart, we will do it.
So which topics exactly should we study for exam?
When is the exam?
5th, I guess.
5th of January?
Yes, if I'm not mistaken.
Sure?
Yes, sir.
So close? Okay, we will discuss with Dr. Azamat and we will tell you which topics you have to prepare.
Okay, thank you.
We will announce it to the class from the WhatsApp group.
So we will also study biostat in next semester?
No. I don't think so, no. This is only in the class 2, isn't it, Dr.
Okay.
Azam?
Yes, it's the course is only for one semester.
Questions on the curriculum and the exams and the technical things you may ask Dr. Azamat. So, other questions? Other remarks? Do you have any closing remarks before saying goodbye?
Thank you, Mr. So much
Okay.
for everything.
I hope we
Thank
will
you,
meet
Hocam.
again somewhere.
Thank you.
You were
Thank you,
all,
Mr.
yeah, you are
Thank you,
all
sir. We learned a lot of new things.
clever guys. I hope you learned something. If you should have questions, we will be always available for you. You can write to Dr. Azamat or to me directly. Don't hesitate. Okay?
Yes, sir, sure.
Okay. So don't forget to fill the feedback form. If you want to say express your thoughts right now, I'm listening. Otherwise, please write them, give them written. Dr. Azamat, do you want to say something before closing the class?
Nothing else, but you should guys pay attention to the things we studied. And if you're going to be a physician, I told you this before, you're going to use this knowledge in the future. Statistics is very important part of our life. I mean, we're living in a world of data. We have a lot of data to analyze, and I think knowing how to do it is a nice bonus for your future career.
And even in the USMLE, they are asking statistics questions, don't they?
Yes, they do. They love statistics. They love public health scientists.
Yeah, public health and statistics is important. Yeah. So, okay then. Kendinize iyi bakın. Take care.
Thank you
Selamat.
again, Mr.
Bye bye.
Hoşça kalın.
Bye.
Teşekkür ederiz.
Hoşça kalın.